All right, we have another composition of functions problem here. And this one, especially the domains on this one, are not going to be near as friendly as the domains on the last one. So the last one was simpler. I did more instruction on that one. Let's just jump in and start working on these. So I'm going to start out with f circle g of x. So I have f circle g of x. It's not fog, that means f composed with g of x. And that translates to, if I read this kind of from left to right, that translates to f of g of x. And that means that I want to take my output of g of x and run it into the input of f of x. And the way I always like to do is write this in stages. And so this is going to be f of, and instead of g of x, I write the 1 over 1 plus x, because that's the output of my g of x. And then I put that into the input of my f of x, which in this case is going to be really nasty because this is complex fractions now. We have fractions within fractions. All right, well, now that we've kind of gotten over the pain that we see coming, we have 1 minus, and then we put in what our placeholder is for x, right? Because this is what I've been calling a dummy variable, right? It's a placeholder for whatever the argument of the function is. Well, the argument of this function is now 1 over 1 plus x. And so now I get 1 over 1 plus x instead of x. Okay, well, now down in the denominator, same thing. This f of x is divided by x. So instead of x, I'm going to write 1 over 1 plus x. There's this little scream inside of me that I'm squelching because this is for YouTube. But yeah, that doesn't look like a lot of fun, right? Several ways to go about simplifying this. The one that I like best for this problem is to take, well, what's technically the least common denominator of all of the fractions within the complex fraction. Well, in this case, that's just 1 plus x. And if I take that and I multiply by 1 plus x over 1 divided by 1 plus x over 1, that whole thing equals 1, and 1 times a equals a is the multiplicative identity, right? 1 times anything, we haven't changed the value of it. We've changed the way it looks, but we haven't changed the value of it. Okay, well, fraction times a fraction, I like to put in parentheses to remind me that it's the denominator times the denominator and the entire numerator times the entire numerator. Helps me keep from making a pretty simple mistake, but a real mistake. Okay, so what do I end up with here? I end up with 1 minus 1 over 1 plus x times 1 plus x divided by, well, the whole idea of this, and I'll go ahead and write it out, but the whole idea of this is that that's 1. But I end up with 1 plus x divided by 1 plus x, which does equal 1, and anything divided by 1 is just like anything times 1, so it just goes away. Now, one thing I do have to note here, though, is that x cannot equal negative 1, right? Because if x did equal negative 1, I'd be dividing by 0. Even though it's canceling out, it's still part of the original function, still part of the cascade of functions. This is just a simplified version to have us do fewer operations when we actually do the calculation. The original function is still what we're trying to evaluate. We're trying to say that the simplified version is identical to the more complicated version. And the more complicated version had the restriction of x can't equal negative 1. So my simplified version must as well, even if I have to manually specify it. Okay, well, let's keep going here. I have 1 minus 1 over 1 plus x times 1 plus x. Well, now I'm going to take that number and distribute it through the parentheses. That's going to be 1 plus x times 1, but I'm not going to write it. And then minus, and then this will be 1 plus x divided by 1 plus x. Well, again, that's going to equal 1, but I have to carry along this idea that x cannot equal negative 1. Okay, well, if that equals 1, what do I really have? I have 1 plus x minus 1, getting ahead of myself here, x not equal to negative 1. I'm really getting just x out of this whole thing. The problem is it's not x, even though x clearly has a domain of negative infinity to infinity. This function, f of x composed with g of x, f of g of x, does not have a domain of negative infinity to infinity. And in fact, there's one more restriction, because I got to go back and look at the original functions. Well, no. That's not the big deal here, because my input. Yeah, okay. And so now I also have to say x not equal to negative 1. If I put 0 into this composition, right, what happens? This, if I put x equals 0 into this composition, this become, well, if I put 0 in as the input to the composition, that becomes 0, so this becomes 1 over 1, and so then I end up putting a 1 into f of x. Well, if I put a 1 into f of x, I get 0 over 1, which is a good number. What I'm having to do is I'm having to find out what number would create a 0 down here, and negative 1 would create a 0 down there. That's what I've been finding when I do that check. Okay, and so if I was to write this domain out, it would be negative infinity up to negative 1, unioned with negative 1 up to infinity, or I would say x such that x not equal negative 1. All right. Let's go ahead and do it the other way, just for a little bit more practice. If I write a couple of lines here, just to make sure we know what we're doing. Highlight all of that, copy it so we can see what we're working on here. Paste that in. Erase those dawdles and erase that because we've already done that. And now, what do I want? I want you to be the main focus. So if that's what I'm finding, let's give ourselves another page because we know we're going to take a little space to do this. All right, my app's getting mad at me now. I got to use 2-finger zoom until we're done. I want to find G circle F. Well, it's literally the opposite order as last time. I'm trying to be very careful with my words here. And so as I run from, if I read this thing, give me my pen back, there we go. If I read this thing from left to right, that is G of F of X, right? That's my translation of G circle F. And so what that means is that if I have G of F of X, that means that the output of F of X becomes the input of my G of X. Well, the output of my F of X is 1 minus X over X. So 1 minus X over X. Don't know what I said, but I wrote it right. 1 minus X over X. Okay, now that then becomes the input to the dummy variable X here. Well, that just goes every place that I have an X on the right-hand side here. And so what I'm really going to be putting in here is 1 minus X over X in place of that X. All right, let's do that. Let's write it down and see if it looks right. I have 1 over 1 plus 1 minus X over X. Now, as far as my domains go, because I really ought to be thinking about this at this point, my domains, because this is the way I've assembled the function, this denominator cannot equal 0. Well, that means that X cannot equal 0, right? That was pretty clear. And then this denominator, that whole thing cannot equal 0. And so if I do that math real quick, I've got 1 plus 1 minus x over x cannot equal 0. Well, we're going to find it equal to 0 and then say it can't be that. All right. Just subtract 1 to the other side. I'll have 1 minus x over x equals negative 1. Multiply both sides by x. I'll have 1 minus x equals negative x. I'm going to add x to both sides. I'm going to get 1 equals 0. What does it mean if I get a contradiction here? It means there's no solution. So that implies no solution, which implies that x not equal 0 is the only domain restriction. Because I don't have any radicals. I don't have to think about square roots of negatives, or fourth roots of negatives, or even roots of negatives. Okay, so I'm done with the domain discussion. Now I need to simplify this thing. Let's take the same approach as last time, and there's only one fraction here, and I want to get rid of it, so I'm going to multiply above and below by x. And so if I multiply by x over x, what am I going to get? I'm going to get x divided by x plus 1 minus x. Well, that's interesting. What then happens here? I get x over 1, which then just becomes x. And then I have a domain of negative infinity up to 0, union with 0 up to infinity. Or I say x such that x not equal 0 for my interval notation or my set notation. All right. I hope that helps us as we work out these problems.